Hello, Nokmak, and in this video, we are going to be looking at a very important interview question called LRU cache, or least recently used cache. Now, a reason this question is so important from the interview perspective is because it not only belongs to the data structures, but it's also a very popular choice of question to ask on the system design questions. And the reason is because you have to build this caching system that you're going to be designing from scratch, and you have to use custom data structure. And that design, that custom data structure requires an in-depth knowledge of fundamentals in data structures. So if you're wondering, in case you're wondering what cache is, the cache is basically a memory that is used to store data. Now, that data is stored temporarily, but the data is stored in a program or an app for faster access for the elements that would be too expensive to look at if you are not using a cache. The cache the cache is basically a fixed size memory that uses various eviction policies that are used to keep the cache fresh and relevant to the use. An LRU, or least recently used, is one of the techniques to keep your cache healthy and fresh to serve programs' need. Now, it uses least recently used eviction policy to remove items that have not been used, so it can make the space for new item to be inserted into the cache. When the cache is full, the cache may determine that, hey, there is no space and I need to find out which item to remove. It's the cache's main responsibility to find an item that it's removing that it does not basically need in the next cycle or next time when programs try to access that value, and it should not be the value that cache just evicted or cache just deleted, and that's the item that your program needs now, because that's going to be an expensive operation. So cache's main responsibility is to be fast and efficient. Now, cache system uses some of the basic requirements and basic required steps to stay relevant. For example, cache needs to be fixed size, and this is important as the cache needs some sort of boundary of limit in the memory to be used. Now, that boundary is needed because your cache can grow as big of a size as there is memory available, and then lookup is going to be an issue, or your program is going to run out of memory. So that's why fixed size for faster access is very important. Now that brings us to the second requirement or required step for a cache system. It's called fast access. Now, cache insertion and lookup needs to be fast, and the preferred time complexity is O of 1. Third, and the most important, is eviction policy. Cache needs to know what kind of eviction policy to apply when the memory limit is reached. It should have an efficient algorithm to evict an item that will not diminish the purpose of the cache. And this policy can keep cache in a good state and stay relevant to the program's need. Now, least recently used cache is basically, or least recently used keyword is the name of the algorithm that's actually used for items eviction when the cache is full. The algorithm is designed in such a way that it keeps a track of recently used entries and the entries that have not been used for a long time. Now, the entries that have not been used for a long time, they're marked to be removed when the cache reaches the memory limit. An algorithm keeps the lookup and insertion time fast enough. Now let's take a look at uh, let's talk a little bit about fast lookup time, right? So when you think about fast lookup time, what comes into your mind? Is it dictionary or hash table, right? Because dictionaries have O of one lookup time because you know after computing the hash where the element is located and you just go and get it. So that is correct assumption that dictionary is actually the fast is the preferred data structure for fast lookup, but it lacks the ability to track which entry has been used recently and which hasn't. So think about it for a minute. How would you overcome that limit when you're using a dictionary? Now, the answer is on the slide. How about using a queue? Queue is a linear data structure, and it can be used to keep track of the items that has been used recently. To track which item is used the most, we take that item that's recently been used and move it to the front of the queue. This idea automatically pushes the least recently used item or most unused item towards the back of the queue. And when it comes to time to remove an element from the cache, all cache has to do is basically remove that item from the back of the queue. Whatever is at the tail, just remove that and put a new item over in the head. Now queues have basically we have seen it building basically from the arrays and from the linked list, right? Now the most common implementation for Lru cache is built using a linked list and commonly and specifically using doubly linked list. And the reason is that for the doubly linked list, the special case is where if you know the address of the node, the deletion, update, insertion of an item is O of one time complexity operation. And the address of the node is something that we're going to save inside our dictionary, right? So with all that now in the picture, it must be getting clear to you as how we'll be designing this cache. So let me elaborate on that. So we'll be taking advantage of dictionary's fast lookup and queue's tracking capability to build this cache. So the dictionary will hold keys and addresses of the nodes, right? So there's going to be key 1 and there's going to be the address of N1 wherever it's located. So this is going to be your dictionary, right? So it's going to hold the keys and the addresses of the node that are there in the doubly linked list. So nodes that are there in the doubly linked list, dictionary is going to hold the address for that. Because we have the address of doubly linked list node, the insertion and deletion will be faster. When an item is used and is not at the head already, we're going to take that item, remove it from the queue, and add it to the front of the queue or to the head of the queue. That operation is going to be O of one complexity because of the nature of doubly linked lists. Now in the next video, we'll actually look at this entire system and build it out from scratch in the code, so that'll actually cement all the concepts that we just discussed about. Okay, so I will see you guys in the next video, and we'll actually build our entire Lru cache from scratch. All right, thanks again for watching, and I'll see you guys in the next video.